Okay, good morning everyone. Is the screen visible?
Yes, sir.
Okay, so start with the next tool for integration, which is a very strong rule. And this type of functions are called the special functions. And the one which we are going to study today is called the gamma function. So, and write down the definition for the gamma function. Consider the definite integral integration 0 to infinity e to the power minus x raised to n minus 1 dx is denoted by is denoted by the symbol gamma of n. Look, this is not under root. Please make this very much clear to you. And this is the sign. It is not a complete under root. It is just a vertical line and a horizontal line. This is read as we read read it as the gamma of n. The integration which you are doing, that the function is called and is called gamma function. So I will write down the definition once again over here. So this gamma of n is defined as integral 0 to infinity e to the power minus x raised to n minus 1 dx. So one thing you need to observe here, that integration that we are going to do, integration is with respect to x. Okay, so when you are integrating with respect to x, these limits are for x. You are going to put the value of x, and the final answer that you will get, that is this n. The answer depends on this n. Okay, so this function is the called gamma function of n. Okay, so why we are doing this and why it is necessary for that, you need to think it in opposite direction. And the opposite direction is that, say if I want to find the integration 0 to infinity e to the power minus x cube dx, can you relate the above definition and the below one? What will be the answer according to this? Anyone?
So gamma of 4 is equal to
Gamma of 4.
4.
Very good. So this is gamma of 4. And if somehow we think that, okay, or we know how to find this gamma of 4, say for example, I'm telling you right now this is 3 factorial, so the answer is 6. So what we are going to do is, whenever I need to solve any integration, I will relate it to gamma, and from gamma I can get the answer. So this is the complete procedure. Okay, so this is how the gamma function is used, and you can see that this looks very much difficult, but in 2 steps we have given the answer. That's why these are very strong functions by which we can find out the answer for a lot of uh, integration. Just a small remark we will write down. A remark: integral 0 to infinity e to the power minus x, x raised to n dx. This will be equal to, as I said, we are going to think in the other way around. We will have integration and we'll find out the answer. So this will be gamma of
N plus 1.
n plus 1. N plus 1. So in all the examples, you will get this kind of thing. If this kind of thing is not there, I will make proper substitution, bring it into this form, and then I will go to gamma. So I should be able to find out the answer. Say if I get gamma of 3, gamma of 4, or gamma of half, so I should be able to find this thing. So for that, we will need proper properties of gamma function, which are very much important. So properties. The first one, gamma of 1 equal to. What will be gamma of 1? By our definition, I'll just do the rough here. Integral 0 to infinity e to the power minus x into x raised to, gamma of n is equal to x raised to n minus 1. So gamma of 1 will be equal to integral 0 to infinity e to the power minus x, x raised to n minus 1 dx. So this becomes integral 0 to infinity e to the power minus x into dx. As x raised to 0, this term will become 1. But what is the integration of e to the power minus x? Minus of e to the power minus x 0 to infinity. When you put infinity, what we are going to get? Minus 1 upon e to the power infinity plus e to the power 0, which is 1. So this term tends to 0 as x tends to infinity. So the answer is 1. So gamma of 1 is 1. First property. Second property, what can you say gamma of 0? Gamma of 0, this will be equal to 0 minus 1. So this will be e to the power minus x upon x.
Sir, zero only, I guess.
I don't think so. So what will happen is x raised to 0 minus 1. So integral 0 to infinity 1 upon x into e to the power x dx. Of course, at infinity, the first term will become 0. But when you put the lower limit, what you are going to get? 1 upon 0. This thing tends to infinity.
Infinity.
So gamma of 0 is infinity. Gamma of 0 is actually not defined. Similarly, we will check for some negative number, say minus 1. Can someone think of it? What if we take off minus 1? So this will be minus 1 minus 1. So this will be e to the power minus x upon x square. So integral 0 to infinity x square e to the power x. What will be the answer?
So we'll get the same time every time if we add a negative number to it.
Yes, so at negative integers, gamma function does not exist. Okay, so at negative integers, gamma function does not exist. Fine. These are some small things, but now we will go for a bit uh, advanced one. Say we need to think of what is gamma of n plus 1. Okay, so gamma of n plus 1, of course, you will say that it is integral 0 to infinity e to the power minus x raised to n dx. But what after that? I need to find the value, so I need to relate it to the gamma of n. Okay, so let's try this. Say gamma of n plus 1 is equal to integral 0 to infinity e to the power minus x raised to n. This is what you will get, right? Now what I'm going to do here is I will apply UV rule. When I apply UV rule, this is U, this is V. So when we have this, so U integration of V is minus e to the power minus x minus integration derivative of U, which is n into x raised to n minus 1. Integration of V is minus e to the power minus x dx. Here you have the limits from 0 to infinity. This is 0 to. In the first one, you can see that when you put the upper limit, this e to the power minus x will become 0. When you put the lower limit, you get the 0 minus. The minus sign with e to the power minus x will make it plus. N being constant will come outside. Integral 0 to infinity e to the power minus x raised to n minus 1 dx. What is this?
Gamma n.
So gamma of n plus 1 is actually n gamma n, and this is the uh, what you can say uh, the result which will give answer for any of the gamma value. Say I said that gamma of 4 is actually 3 factorial. Now how do we get that? Here is like this. Say gamma of 4 will be equal to now. So if I want to find gamma of 4, this is 3 gamma 3, because 4 can be written as gamma of 3 plus 1, right? So this 3 again I can write as gamma of 2 plus 1, which will be 3 into 2 gamma 2. But now 2 can be written as 1 plus 1. So this is 3 into 2 into 1 into gamma of 1. We know that gamma of 1 is 1 from the first property. So what is this? This is 3 factorial. Okay. So this is how we are going to find the gamma value. So I'll write down the fourth property. This is n gamma n. So the fifth one, I'll just give the characterization of this. If n is positive integer, then gamma of n plus 1 is, yes, be quick with this. What you are going to get? You can just use the fourth property. I don't know why it is so much difficult for you. So gamma of n plus 1 will be n gamma n. Again, n gamma n will be written as n minus 1 plus 1. And you'll go on reducing it. So what will be the final thing that you get?
Factorial of n plus
n factorial.
N factorial, exactly. This will be n factorial. But the point is, gamma function can also be defined for rational numbers. Okay, and in the same manner we are going to define it. So just a quick example for understanding here, that if I want, okay, before that, I'll write down the sixth property. Gamma of half is equal to under root pi. The proof, we won't discuss the proof as it is quite lengthy and difficult. So I'll give you the proof, but we'll use some advanced technique later and I will give you the proof. Okay, so what I was talking about is if I want the gamma function of some rational number, say 5 by 2. 5 by 2 again I can write as 1 plus 3 by 2. So 3 by 2, gamma of 3 by 2 just by the previous property. But 3 by 2 I can write as 1 plus 1 by 2. So 3 by 2 into 1 by 2 gamma of 1 by 2. What is the answer? 3 by 4 gamma of half is root pi. So 3 by 4 root pi. This is the final. Okay. So if you have denominator, so you can get to the final answer. The denominator is 2, then you can get to the final answer by just reducing it. You write that term as 1 plus n plus 1 and n gamma n and go on using the same property again and again. If there is something else than 1 by 2, then we can leave it over there. Fine. Say, what if I want to find the gamma of minus 1 by 2? Gamma of minus 3 by 2. Say. Can anyone suggest something for this? If you are not getting this, I'll write this down as a minus 1 by 2 first, and then we'll think of minus 3 by 2. Can you use some of the property, make some change, and get to this? Anyone? You tell this and 100% that person I'll give you 2 marks for free when I do the final calculations of your CCA. This is on record. I'm telling you. Think of an idea by which I can find gamma of minus 1 by 2.
Sir, in the fourth property, we can place n as 3 minus 3 by 2.
3 as?
No, n as minus 3 by 2. But
N
still
as
we will
minus.
get confusion.
You are
So
somewhat
replace
right.
minus with iota square.
You replace? What's the
Replace
previous
minus
one?
with iota.
So we can use iota here.
No, no. It is not under root. I said that earlier. Don't think of under root. Who was the first person to speak?
Yes, sir. Utkarsh.
No, no, no. There was someone before you. I think it
Sir,
was
Sumedh,
Sumedh.
sir.
Sumedh, yes. Sumedh, you are on right track, but not exactly right. What will happen if you place
try
n as
harder.
place n as minus 3 by 2? Do something in your notebook and see what you get.
Sir, we will get minus, still we will get the same thing.
Tell me.
Gamma minus 1 by 2 in that.
Minus 1 by 2 plus, equal to minus 3 by 2 gamma of minus 3 by 2.
Yes,
Huh.
that's what I was saying.
What about this minus 1 by 2 then?
Sir, we can place minus 3 by gamma minus 3 by 2. We can write it as gamma of minus 1 by 2 plus 1.
So can we do like this that we have the value of gamma 1 by 2. So
Uh,
we just put n as minus 1 by 2 only. Then minus 1 by 2 plus 1 will give us 1 by 2.
yes,
Gamma of 1
others.
by 2.
So what we will have? Gamma of 1 by 2 is equal to minus 1 by 2 into gamma of minus 1 by 2.
Gamma of minus 1 by 2.
This is under root pi is equal to minus 1 by 2 gamma of minus 1 by 2. So what is gamma of minus 1 by 2?
Minus 2 root pi.
Exactly, minus 2 root pi. So this I can substitute it here. So minus 2 under root pi is equal to, so this will make it minus 4 plus 4 actually by 3 gamma of minus 3 by 2. Very good. So Adarsh and Sumit, what are your roll
Yes.
numbers? Let me just note it down.
Yes.
Yes, tell me.
So others 64. 118064.
Sir, Sumit Kasat
One
118076.
118076. Okay.
Yes, sir.
So I'll just sum up. You have done it, but there's a modification which can actually lead us to this. The small modification is that I have to increase the value. So look, our target is gamma of 1 by 2. So when we were ahead of 1 by 2, what we did was we used the property n plus 1 is equal to n gamma n. Say if I want to find gamma of 5 by 2, the idea was I am going to reduce it to get gamma of 1 by 2. Okay, so you are reducing. So when I want to find gamma of minus 5 by 2, what I should do is I should increase it and get to the gamma of 1 by 2. So in order to increase this, what I do is I modify this and I write that gamma of n is equal to gamma of n plus 1 upon n. Okay, so this is the modification which we use. अगर negative है, you go on increasing it up to gamma of half. Say now by using this property, you can see that if I want to find gamma of minus 3 by 2, this will look much easier. Say minus 3 by 2 will become gamma of minus 3 by 2 plus 1 upon minus 3 by 2, which is minus 2 by 3. This gamma of minus 3 by 2 plus 1 is gamma of minus 1 by 2. But gamma of 1 minus 1 by 2 again I have to increase. So use the same property, that will be gamma of minus 1 by 2 plus 1 upon minus 1 by 2. So this can further be simplified as minus minus will become plus 4 by 3. Gamma of minus 1 by 2 plus 1 is gamma of half, and which is root pi. Okay. So we have just made a small modification there and we have got this property. So if I want to increase the value, you should go by this rule. If we want to decrease the value, we should go by the earlier one. Fine. I hope everything is clear now. So as we are going to go for example, so please note this seventh property. Gamma of n is equal to gamma of n plus 1 by n. This property is basically used whenever you will have negative rational numbers. Fine. Before going to actual examples, I will just discuss, okay, when you have certain kind of integration, how can you reduce it to gamma? So what kind of substitutions we are going to use, and that you will have to think. I will just write down the type of integration. You think what substitution you can do so that you will get the required gamma function there. Okay. So first of all, let's write down the integral 0 to infinity e to the power minus x raised to n dx. So the value of this is gamma of n plus 1. So value of this integration is gamma of n plus 1. We know what is the value of gamma of n plus 1. It may be n factorial or something. So this is our milestone. Whenever we have an integration, I need to think of some proper substitution so that finally it will reduce to this and I can get the gamma function and give the answer. So first type that I want you to think about is when we have integral 0 to infinity e to the power minus ky y raised to n minus 1 dy. Yes, anyone? K is a constant number over here. You compare these two things and you will get some thought.
So gamma n upon k to power n.
What is the substitution so that you can convert the given integral to gamma function?
Sir, can you explain this page again, because I'm not understanding what is doing.
What I said is you have this integration as your milestone. Okay. Once you get to this kind of integration, you can directly give the answer, which is gamma of n plus 1. So every integral, in every integral, our main objective is to make some proper substitutions so that that integral will be converted to this form. And once we get this form, I can give the answer. So my question is, if this kind of integration you need to solve, what substitution you will make so that it will be converted to this form? E to the power minus of variable into variable raised to n. This kind of thing you should get.
Sir, ky is equal to x.
Exactly. So what we will put is ky is equal to t for an example. So the integration will be e to the power minus t. This is what I should get. This term I should get always. If this term you cannot get, then you won't be able to solve it. So you think of a proper substitution so that you will get e to the power minus of this variable. Fine. Next, the second one. While solving examples, we'll see how the substitution has to be done. There is a proper technique for it.
Sir, then what will happen to y n to the power y to the power n minus 1? Sir?
What is the value of y? Y is equal to
Y
t
is
by
equals to, yes.
then
So,
this
so we are
k
not
is a
getting
constant, na? K is a constant. So t by k raised to n minus 1, which is nothing but t raised to n minus 1 upon k raised to n minus 1. But k क्या है? Constant है. Constant can be taken outside the integration, right?
So there we want n, no sir.
Yes.
e to the power n minus 1 नहीं चाहिए ना, n चाहिए ना.
बट n-1 का भी आंसर मैं निकाल सकता हूँ ना.
ओके सर, ओके गॉट इट.
n-1 होएगा तो RHS में अपना सीधा गामा n
गामा n हो जाएगा. एग्जैक्टली. तो नेक्स्ट वन e to the power minus y raised to 1 by n even. So in this type one, we'll put y raised to 1 by n as another variable x, right? Once we put 1 by n is equal to x, this will mean that y is equal to x raised to n, right? So this kind of substitutions you need to do. The third one, integral 0 to infinity x raised to a upon a raised to x dx. Now this is a bit tricky over here. 0 to infinity, I'll just simplify this. X raised to a into a raised to minus x dx. So in this type of integrations, what we need to do is we need to put this term. I have a constant raised to variable. So what substitution you need to do is put a raised to minus x as e raised to minus t. Okay. So if you make this substitution, so you can see that the value of x is going to be minus t upon log a, sorry. Okay. So everything will be sorted out. Just you can see the substitution. Fourth and fifth, I'll just write down for log of 1 by x in integrand so put log 1 by x as t. For log x, put log x equal to minus t. Why this substitution? You can see that in the above one, you will get 1 by x equal to e to the power t, which means that x is e to the power minus t. Again, in this one, you can see that x is equal to e to the power minus t is something that you will get, which is most required for the gamma function. So our ultimate task is whenever you look at an example, you think of a substitution so that you will get e to the power minus x and x raised to something over there. So I hope all these things are clear and I can go for examples now. First of all, easy example. Okay. Evaluate. Evaluate integral 0 to infinity e to the power minus root x into fourth root of x dx. Yes, anyone?
Wait a minute.
What is the substitution? Tell me the substitution, just the substitution.
So root x t.
power
X
minus
is
x
t raised
into
to
Root x or minus root x?
So root
minus
x.
Root x equals
Root
to
x. Root x equals to t की power 4.
so that will make it x equal to t square. Very important remark. Whenever you look at this gamma function integration, always keep this habit. if you want to get to the correct answer, because the main or the what I can say is the crux of these examples lie in the substitution. If you do the substitution properly, you will get the answer, because after the substitution everything is easy, just the substitution. And I'm giving you a trick to do the correct substitution, and the correct way is always find out the value of x. Okay, so whenever you make some substitution, from that substitution get the value of x. Once you get x is equal to t square, now you can do your further things. What is dx? Dx is equal to 2t dt. Then if x is equal to 0, then you can see that t turns out to be 0. If x equal to infinity, then t is equal to infinity. You are not going, you may not get the chance to give the theory exam, but if you, I mean, when theory exam used to happen, just this much step carries 2 marks. You can see that how much important substitution is over here. Fine, let's put the values. So we will get integral 0 to infinity e to the power minus of t. You have x raised to 1 by 4 over here. You can see that. So what is the value of x? It is t square raised to 1 by 4. The value of dx is 2t dt. So 2 being constant will come outside. Integral 0 to infinity e to the power minus t. So this will be t raised to 1 by 2 plus 1. That is t raised to 3 by 2 dt. What is this? 2 times, by definition of gamma function, this is gamma of
5/2.
5 by 2.
And
Exactly. Gamma of 5 by 2. But this can be simplified, right? Gamma of 5 by 2 can be written as 1 plus 3 by 2. So this is 3 by 2, gamma of 3 by 2. But 3 by 2 again can be written as 1 plus 1 by 2. So 1 by 2, gamma 1 by 2, which is under root 5. So the answer is 3 under root 5 by 2. Clear?
Yes, sir.
Should I go ahead?
Yes, sir.
Exam. Evaluate integral 0 to infinity x square upon 3 raised to x square dx. Let's simplify this first. So what we'll have, 0 to infinity 3 raised to minus x square into x square dx. Substitution.
x square equals to t.
But x square equal to t will give you 3 raised to minus t.
3 raised to minus x square is equal to e raised to minus t.
Yes, exactly. 3 raised to minus x square will be equal to e raised to minus t. Okay. So for simplification, what we do is, I said that the trick is you find out the value of x first. So to find the value of x, I'll take log on both sides. I will have minus x square log t is equal to minus t log e. Log e is 1. Minus will get cancelled out. So x is equal to 1 upon, t upon log 3. total raised to 1 by 2. Clear? Now, if x equal to 0, then t turns out to be 0. You can check that. You can put that in this expression. If x is equal to infinity, then t also has to be infinity. What's the value of dx? Log 3 being constant 1 upon under root of log 3. What's derivative of t raised to 1 by 2? Derivative of root t?
1 by root t.
2 root t.
1 by 2 root t.
Let's put these values in our integration. So this is equal to integral 0 to infinity e to the power minus t. What's the value of x square? X square is actually t by log 3. Dx is dt upon 2 under root log 3 to root t. Let's simplify this. Take the constant term outside, 1 upon 2 log 3 raised to 3 by 2 log of 3 raised to 3 by 2, then integral 0 to infinity e to the power minus t 1, and you will have this denominator में root t है, so 1 minus 1 by 2 is t raised to 1 by 2 t. The answer is gamma of 3 by 2.
M 3 by 2.
So gamma of 3 by 2 is going to be 1 plus 1 by 2. So 1 by 2, gamma of 1 by 2, which is root pi. So answer is 1 upon 4 log 3 raised to 3 by 2 into under root. Fine.
Yes, sir.
Evaluate.
Sir, can you take the previous slide notes? Done, sir.
Evaluate integral 0 to infinity x raised to 2 upon 2 raised to x d. This can be written as integral 0 to infinity 2 raised to minus x into x raised to 2 dx. We'll put 2 raised to minus x as e raised to minus t. Take log on both the sides, so what we'll get is x log 2 is equal to t. So dx is equal to dt by log 2. If x equal to 0, then t equal to 0. If x equal to infinity, then t is equal to infinity. Put the values in the integration. So we'll get integration 0 to infinity e raised 2 raised to minus x is e to the power minus t. Then you have x square, but x is t by log 2 square. Dx is dt upon log 2. So if we solve this, we get 1 upon log 2 cube integral 0 to infinity e to the power minus t square dt. What's the answer for this?
Upon log 2 cube.
Gamma of 3 on log 2 cube. What is gamma of 3? It is 2 factorial. 2 upon log 2 cube. And solve just one last example, then we'll stop. Example. Evaluate integration.
Previous slide, I did not complete.
Yes.
Just done, sir.
Integration 0 to 1 log of 1 by y raised to n minus 1 dy. What's the substitution?
Log 1 by y is equal to t.
Log 1 by y is equal to t. So this will be 1 by y is equal to e to the power t. So y is equal to e to the power minus t. So you can see that if y is equal to 0, then t is equal to
Infinite.
and if y is equal to 1, then t equal to
0.
0. Moreover, dy is equal to minus of e to the power minus t dt. Let's put these values. So we'll get integration infinity to 0. Log 1 by y is t, so t raised to n minus 1. The value of dy is minus e to the power minus t dt. So this is actually minus infinity to 0 e to the power minus t raised to n minus 1 dt. So minus of integration e to b f of x dx. By properties of definite integral, this is 0 to infinity e to the power minus t raised to n minus 1 dt. So the answer is
Gamma
gamma n.
n.
So that is all about the gamma function. We have ended the topic gamma function. In the next lecture, we will see beta function. If you have any difficulties regarding these, please ask.
No, sir.